So here we're asked to simplify the expression, and if we have a square root with the root index of 3 of 64, what the root index means is what number do I need to multiply by itself 3 times in order to get 64, right? So what we need to do in this case is we can convert the 64 into its factors and see if there are 3 of them that we can pull out. Okay, so let's do that. We have square root, or maybe I can do my work down here. I do square root with the root index of 3 of, well, this is 8 times 8, right? But that's not 2 factors. That's 2 factors, not 3. So maybe we could start with 2. We could say 2 times 2, which is 4, times 2, which is 8, times 2, which is 16, times 2, which is 32, times 2, which is 64. Alright, there we go. And the root index being 3 means every time we have 3 numbers multiplied by themselves, which are the same numbers, we can pull them out of the square root. Right? So here we can pull out the 2 because we have 3 of them. And here we can pull out the 2 because we have 3 of them. So what this is going to equal is 2 times 2. Right? So what that's equal to is 4. 64, square root of 64 with the root index of, the root 3 of 64 is equal to 4. Let's go ahead and take a look at number 8. And here we have root 4 of 10,000. And so what are 4 numbers that multiply to each other to get 10,000? Let's go ahead and try that. So let's do square root. Let's do root index of 4, and we'll have a 10 times 10 times 10 times 10. That's 100, 1,000, 10,000. So it works out. So what this is going to be equal to, since we have 4 tens as factors of 10,000, we can pull it out. So it's equal to 10. Alright, so to simplify this expression, right, it is in rational exponential form. And so we need to first convert it from rational exponential form into radical form, and then we can evaluate and simplify the expression. Right? So let's go ahead and do that. We'll get the cube root of 27 all to the power of 2. Okay? Remember, the denominator of the rational exponent goes into the root index, and the numerator is what the entire term is raised to the power of. Alright, so to evaluate this or simplify it, we need to find out what the term inside the parentheses evaluates to. So let's do that. 27 is equal to, and we could say 3 times 3 is 9 times 3 is 27. Right? So since we have 3 multiplied to itself 1, 2, 3 times, we can pull it out. Right? And so what this is going to equal is 3 to the power of 2. Right? Because the cube root of 27 is equal to 3. So 3 to the power of 2 is equal to 9. Alright, let's go ahead and try that again here with 256 to the power of 5 divided by 4. First, we need to change it from being a rational exponential form into its radical form. So what we'll get is the 4 goes into the root index, and we have 256, and the 5 is what the entire term is raised to the power of. So now what is multiplied by itself 4 times to get 256. Let's see. Well, since we have a 2, an even number as in the ones place, we can start with 2. Right? So we have 2 times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, times 2 is 128, times 2 is 256. Is that right? Let's see. We have 2 times 2 is 4, 8, 16, 32, 64, 128, and then we'll do times 2, which is 256. Alright, so our root index is 4, so since we have 4 2's here, we can pull it out, and since we have 4 2's here, we can also pull that out. So what this is going to become is 2 times 2, which is equal to 4. Okay, and so that's all to the power of 5. So let's go ahead and rewrite this as it's equal to 4 to the power of 5. And so let's see, what is 4 to the power of 5? 1024.